Hi, my name is Chris Sequeira. By day, I work at the Federal Aviation Administration, doing a couple things. One is managing the production of an environmental analysis software program, and the other is managing a couple projects that look at how aviation affects air pollution. I just give that as an intro because I'm actually here for my personal time. FAA hasn't sent me here, so it's just kind of my own thing, but it's given me a little bit of background on air quality and modeling. And my question is for Dr. Whitlow. You talked about the measurements and your unexpected findings there, and I'm curious to hear at what level did you characterize the chemical environment, and at what level did you look at the different kinds of particles that make up this mess of different sizes and chemistry that we call PM. So in my world, we typically look at a couple kinds: nitrates, sulfates, organic aerosols of both primary and secondary, and then black carbon. And we see that, especially with distance, the chemistry can change in the atmosphere, affected by meteorology, obviously affected by the emissions themselves, and affected by the things that take up the particles. So, for instance, certain gases will condense into particles at certain timescales and distances, and I'm interested to hear how you interpreted your findings from that perspective.
Is this on?
Yeah.
We've just looked at the criteria pollutants, PM 2.5 and PM 10, although we have looked at it as 15 different discrete particle size classes. There are about 150 different things that end up in the atmosphere, and they do change very rapidly as a function of distance and time, depending on the population mix of things that are actually in the air. I've focused on PM specifically because it is a criteria pollutant, and it's something that's widely monitored, perhaps one of the most frequently monitored things by state departments of environmental conservation. So it's potentially generalizable across cities and things like that. If you were to, well, I decided that looking at the particle mix in the different size fractions, that was going to be a very daunting process, and I thought that it might be better to look at an integrator, a biomarker. So that's why I kind of went to this pro-inflammatory cytokines that would integrate all of this stuff. Now, it would not take account of things that existed in a gaseous form directly. So I thought that we might be able to integrate and express things in an all else being equal human health outcome sort of matrix, so to speak. So we have not really looked at the composition of those different kinds of things. It's strictly particle counts, and you're kind of asking, your question is really the next frontier from a measurement and regulatory perspective, and it would require an order of magnitude greater investment in equipment and data collection effort. But excellent question, and certainly the fact that particle sizes, the distribution of particle sizes changes very rapidly over time. That's another variable. It's not a constant, like it comes out of one place and then that's constant and we can look at the decay strictly. This is a very dynamic kind of population. So thanks for your question.
Thanks, Marina. My name is Morgan Grove. I work for the USDA Forest Service out of Baltimore. And I wanted to share a little bit of validation in terms of what Diane was talking about. Along with Mike Galvin, I helped to run our Urban Waters program, which is a whole joyful experience of trying to get 15 now federal agencies to work together on the topic of urban water. And when we ask our local partners what do they want, one of the key things that they say they want is they want good scientific data on green infrastructure activities that will be accepted in a regulatory context. So exactly what you're saying, Diane, about the need for us to look at how we design these things and to document their performance, and that other federal agencies will accept them for regulatory compliance. It gets a little bit more complicated, though, because the models that are being used to look at these are important as well in terms of what the assessments or the assignments are for these urban areas. So, for instance, Baltimore, according to the Chesapeake Bay models, let's say every city's got to be at 10 whatever, okay? But the models say, based upon the data that's brought in, that Baltimore is at 50. And so their regulatory permit, they have to submit a permit that says that they have to get from 50 to 10. But the cities think they're really only at like 25. And the difference in money, trying to go from 25 to 10 or 50 to 10, what they have to do in terms of assigning their, coming up with their permit and what they're going to spend their money on is in the hundreds of millions of dollars. So we need to get the models of assessment better. Because this is, like I'm saying, this is billions of dollars that individual cities are having to spend on this. So there's real money in the game. And then finally, when you talk about hyperfunctional landscapes, which is awesome, we need to tie that hyperfunctional aspects to these regulatory requirements. Because when we're working with our jurisdictions, they love hyperfunctional, but they're still saying, show me how it's going to solve my programmatic and regulatory requirements. And if you can do that, then we're going to have a lot better success in working with our local partners, not just the city agencies, but also all those nonprofits who are also looking to solve these problems. So that would be what I would encourage when we think about the hyperfunctional piece, is to tie it to those regulatory pieces where we know that money has to be spent. Thanks.
More questions? Yeah.
So my name's Gary Bell, and I work with American Rivers. We do a lot of green stormwater infrastructure work. And one of the things I heard a little bit about, and I'd like to hear a little bit more, is the social perception of a lot of this hyperfunctionality and these different techniques. For example, one of the things that was said was that green stormwater infrastructure, a lot of the things that we could do by doing more research into the clean water aspects of it, the pollutant reduction loads. But when we've done installations, we found that a lot of people are less interested in the sediment removal and much more interested in local flood reduction of these techniques, because that's the social interaction that they're having with their neighborhoods. And so I just guess there's that sort of extra X factor in how you do these things. You sort of are going along a scientific pathway, but you have this sort of irrationality of the way people perceive these functions, and how do you start to incorporate that into the equation?
Can I make a comment? I think that we talk a lot about irrationality, but that maybe that's not the best place to approach dealing with the community, because, you know, people have community values for various reasons, and, you know, we're not going to get around flooding concerns. It's a real concern. If my property was along a creek, I wouldn't want my house to flood, and that sort of a thing. So you know, the hyper functionality should take into account, I think, some of these trade-offs that we are going to have to do with flood control in cities. And when we do these stream and river restorations, I mean, there's talk of dechannelizing the LA River, for example, but there's no way that a project will be allowed to go forward that will increase flooding regimes in the city of Los Angeles, in downtown Los Angeles. Hyperfunctionality, to me, will optimize, like Rich, you were talking about optimization tools, and they should try and optimize all those outcomes, because I think that there are designs that can enhance pollution removal while still, you know, utilizing flood control methods. So to me, we should determine what the community values, and to a certain extent, unless their assumptions just really are wrong and not consistent with scientific data, try and have these designs deliver what they need, as well as what is required by regulatory standards. And that's a high bar. I understand that's a high bar, but it's done in urban planning often for the built infrastructure. We just need to shift now to looking at green infrastructure.
Is this working now? Oh, good. No, that's a very good question. And it kind of relates to, I think what we're all getting at here is that part of the public perception of what is being proposed, you have to give them the information that they need to really help them make the decision about what's good for their community or not. And we have to be able to present that information so that it's understood. You know, some of Tom's graphs probably aren't going to work. Sorry, Tom. But certainly, I think when we get into uncertainty analysis, risk analysis, and things like that, people buy insurance all the time. You know, people have and so if we can help them understand the risks involved and provide the information in other ways that they can understand, I think we can get them to make better decisions. Because I really feel strongly about this. I think that, and Tom was alluding to this with the stream restoration, that a bad decision is actually worse than not making a decision at all. And so we really want to minimize those bad decisions. And so we're going to have to figure out a way to make this understandable as science community so that people can digest this information and make good decisions. And it's also the managers as well. Managers need to have an understanding of the uncertainty involved with, we have all kinds of models, we're giving them numbers, but what do the numbers mean? We don't really give them that much background on what these numbers mean. And so I think it's going to be a long and evolved process.
I'd like to say something about rationality for just a minute. I suffer from engineering envy, perhaps, and hydrologists and civil engineers have this model, the rational model for calculating runoff. And rational means basically this is a transparent process. Here are the assumptions. Anybody going through this process should come up with an identical kind of conclusion. So it doesn't mean rational or irrational it's not a synonym for hysterical. It's rather transparent and straightforward so that it's verifiable. And I think a lot of people do get the idea, at least in concept, of things like the 100-year flood. And there's a discussion in the literature now in a wide range of publications about probability and risk and things like that. I think intuitively we kind of know that living in the 10-year floodplain is a worse thing to do than living in the 100-year floodplain. So any of our rational decisions that's intended to achieve a predicted effect has a probabilistic component to it. And if we exceed the design, okay, if this is the 50-year flood, then you're okay. If it's the 100-year flood, you're not okay. I think that's nuanced, but people do in fact sort of get it. And I think that communicating that is a little tricky, but I think we can probably do it.
Thank you. Yes.
I'm sorry.
Yes, this is for Richard Puyat. I'm Sandy Spencer. I'm at the Patuxent Research Refuge. It's a national wildlife refuge, actually. And early in your talk, you mentioned that there were some natural habitat and species assemblages that are forming now, and that's very intriguing to me. What are some examples of this? Are these just like some usual suspects that just kind of happen, but in repeated patterns? And is there some like functionality aspect to these assemblages now with respect to like groundwater recharge or soil complexity and mycorrhizal relationships or serving as native host plants? Is it that functioning?
Yeah, I mean, it's a good question, but we largely don't know. So the point I was trying to make is that through our practices of introducing species intentionally, unintentionally, changing habitats, we're bringing together assemblages of species that haven't co-evolved. And so you go to a tropical rainforest that, they've been co-evolved for, millions of years. And so we're just sorting, these things are just sorting themselves out. So it's largely unknown how they function. But, if you walk around New York City parks, for example, if I had time, I would have showed you a slide of one of these habitats, but there's an island just off of the Bronx in which you get this beautiful 150-year-old oak forest, and then there's ailanthus trees growing in patches where some trees came down, and underneath those ailanthus trees is daylily. So where did you ever see that, forest composition anywhere on the planet? Probably nowhere that I can think of. So but the thing is, we don't know how they're functioning. And then the other aspect of introducing, and we know this from island biogeography, you introduce a predator where the local species haven't had a chance to adapt to, they have a huge impact on the population. And so my little Vinny, I don't let him out of the house because he's going to kill birds. And we've already demonstrated that, these domesticated cats can have a huge impact on bird populations. But it's just the tip of the iceberg. We really don't know. It actually makes it kind of exciting as an ecologist. This is a new frontier. Gary's talking about that. And for ecological research, it absolutely is. But how it functions with carbon and nitrogen, all bets are off. We don't know for sure. That's a good question.
Hello, my name's Guy Robertson. I'm with the Forest Service in research. I don't work in urban forestry. Actually, I do sustainability reporting on natural forest ecosystems. But looking at some of the stuff that was talked about today, I'm curious. I mean, it looks like for a long time, people have been planting forests and our trees in urban areas. I come from Portland, Oregon. The value of that investment is fairly manifest when you start walking down the streets and you see the urban greenery around you. But at the same time, it's also a very expensive thing to do. And so cities have been, I'm sure, struggling with the question of how much to spend, how much do you get back. It's a long, old question. So I guess my question is, given the fact that we've been looking at the broader ecosystem services, the values associated with forests, are we right now seeing an evolution or a revolution in the way we do urban forestry? Are we planting more trees? Do we anticipate this sort of revolution in the future, both in terms of scale or in terms of the actual way we do urban forestry? Is it something that's going to change in 30 years if I walk down the streets of any of these cities that would be engaging in this activity? Would I see a difference?
So can I ask, is Stephanie not going to present?
No, I just said.
Yes, they're just going to hand out her presentation. That's what her
unfortunately.
presentation was going to be about. So actually, Stephanie's perspective, let me try and summarize. I'm going to do a very poor job of paraphrasing. Stephanie Pincel is a social scientist, so her training is radically different than mine, so I don't summarize her research very well. But she was going to talk about the history of urban forestry, and actually that's a very, very new phenomenon in cities because public tree planting really dates back to Olmsted, and before that, cities had no public green space. We don't have a history of that. We don't even have the right concepts or the right language to talk about what is an urban forest. We use the term forest, but we're really talking about assemblages of trees. I mean, it's not actually that analogous to a natural forest in some respects. So in addition to that, Stephanie's research focuses a lot on the institutional structure of cities, which is very poorly optimized to manage trees. As many of you know, when we analyzed tree planting in LA, it's spread around all kinds of different departments. There are public-private partnerships. The way that the programs get funded is extremely complex, funding coming from all kinds of sources, not enough of it. So actually, if we really want to talk about this revolution 30 years down the road, city government needs to be reorganized in ways that we are just now talking about, and we should talk about at this meeting. And unfortunately, as an ecologist, I'm not the right person to talk about it, but I'm sure many people here are.
Thank you. This is Phil Rodbell with the U.S. Forest Service Urban Forestry Program, actually. And while Ann is here, I thought I would ask a question. But obviously, there's a lot of new vocabulary here, and it's wonderful listening to it and hearing from an ecological perspective how they characterize cities and urban ecology. All of our cities are making huge investments right now in green infrastructure and new techniques what we don't seem to have is a really strong research collaboration occurring in our cities along the multidisciplinary line that has been discussed here that is needed. I'm wondering what kind of conversations are occurring nationally to support cities. They can afford and have a role of implementing these innovations, but monitoring and reporting out on those is the biggest challenge. There's a gap. There's a lot of things happening in cities that we're not capturing. I'm wondering if there's been a conversation nationally at the federal level to help in leading that conversation and spurring. I know the ultras is one response to that. Is there some continuing investment in that area?
There probably are some people in this audience who are better informed on this subject than I am, just because there has been a continual, I think, dialogue, and Morgan mentioned the urban waters. I think that's the kind of effort that's going on, that's bringing the different agencies and departments together about what are the science needs associated with it. It's not happening at that scale at USDA as a whole, and that was one of the comments I made earlier, is I think we could do a lot more, certainly in partnership with the other agencies that have a stake in the whole urban infrastructure, urban environment. So we probably should be doing more, and I guess I would say that this meeting, coupled with what the National Academies has been doing with the sustainability workshops and the one coming up in Portland. In fact, if my National Academy folks are here, we ought to structure that Portland agenda building off what we just learned here, because I think there's some very natural connections. So we do need to increase the amount of discussion that's taking place. Now, I'm hopeful that given what I learned in preparing my remarks for this meeting, there has been a lot more development and evolution in the science that's being done than I was aware of when I left Forest Service three years ago, I guess now. And so that's very hopeful that even though it's sort of below the radar screen in some departments, it's still continuing to happen. So maybe this is the type of meeting that pushes it forward. But I'm also very intrigued by its regulatory context. What is the push and the pull that, what is the setting in which we are doing this work? We should be understanding from the regulatory agencies what they need to make better decisions, and be building our research in support of that, as well as the fundamental principles.
I have been asked to say that this is the end of our session. I apologize because we have other people that are interested in asking questions. We have a session in the afternoon that will take care of that, because the working group session will be about specifically the questions we have asked this morning. So I'd like to thank again our panel and our keynote speakers for a great job today. Thank you. And we have 15 minutes. We have a break now, and we will reconvene at 11:15.